Okay, the last page of this review covers our section on creating quadratic equations. So you can use any of the methods, and some of the questions on the test will be multiple choice. Others you will need to create the equation on your own. So looking at this first one, 14, it says create a quadratic equation that has a vertex of 5, -3 and passes through the point 1, 5. Now remember, as soon as we see vertex, we automatically know that this represents the like h and the k in an equation. So I can create most of my quadratic equation just by putting in that like h and that k. And remember, the h and the h always goes in here, and the k value goes outside here in our vertex form. So we would put -5, and then we would put that -3 on the outside. So this is essentially what we're looking at here, and we just need to figure out the a value to know how to stretch or shrink it so that it will pass through this other point they gave us. So remember, we use that point as like an x and y value that work in this equation. So we would put the y value in where our y value is. So 5 is equal to, we don't know the a value, we put the 1 in, and we have squared -3. So if we're looking at this and I simplify, I get 5 is equal to a times, we start inside the parentheses, so 1 minus 5 is a -4. I'm going to keep going here. If I do -4 squared, because we do exponents second, that's 16, so 16 times a, and you still have that -3 on the end. So I'm going to add the 3 over. I get 8 is equal to 16a. Then I can divide by 16. So a would be equal to, if I simplify that fraction, that would be 1/2. So our final answer is just putting that 1/2 into that original equation. So this would be y is equal to, there we put the 1/2, and then we have our x minus 5 squared -3. And then you could always graph that if you wanted to check that that worked. All right, let's do one more of those. Again, as soon as we see that it says vertex, we label that h and k, and we plug that into our equation. So we go a times x minus a -2 would make that +2, and then +4 on the end there. They give us another point that it needs to pass through, so that gets to be our x and our y. So I'm going to put -2 in for the y, and 1 in for the x. Then we're going to simplify, again starting inside the parentheses, so we get 3 squared. And if we square that 3, we still have -2 equals, that's 9 and a, so 9a. We have +4, so we minus the 4. -6 is equal to 9a. We divide by 9. And a is equal to -2/3. So again, we finish by putting that in to make the final equation. We get y is equal to a -2/3 x plus 2 quantity squared plus 4. Okay, there's our equations. 16 says it has x-intercepts, -3, 0, 3, 0, and passes through to -18. Again, the fastest one to use on this is to use intercept form. So as soon as I see intercepts, I kind of know that I want to use intercept form. Let me remind you, that's just the factored form. So we write x minus this and x minus that, right? And our x-intercepts are those pieces that can just sneak right on in our equation. So whatever those x-intercepts are. So we will have y is equal to a, x minus a -4 makes that +4. And then we have x minus 3. Just like the last ones, you're given another point that it needs to pass through. That can be like an xy. That's going to work to help us find the a value. So a -18 would be that y value is equal to a. We get 2 as our x value up there that's given. So 2 plus 4, and then there's another spot to put the x in. So everywhere there's an x, we go ahead and put that 2. Then we simplify. So remember, we start inside parentheses. So 2 plus 4 is 6. 2 minus 3 is -1. Remember, parentheses mean multiplication. So you've got -1 times 6 is -6 times a. That's -6a. And then we have our -18. So we divide by -6. And it looks like a is equal to 3. So for your final answer, you're going to put 3 in for that a value. And you've got x plus 4, x minus 3. Okay. Again, you can use the calculator method on this one because there is at least 3 points, but just walking through that process so that we can kind of see that. Again, if those are my x-intercepts, I go y is equal to x minus a negative 5, so I'm going to put plus 5, x minus that negative 1, so we're going to put plus 1. Again, we're given a point that it needs to pass through, so xy, that helps us to find that a value. So y, oops, not y, negative 3 is our y, is equal to negative 4, x plus 5, x plus 1. But instead of x, whoops, I should have put in, oh, this might erase my whole thing. Guess I'll just rewrite that. That negative 4 right there as my x. So negative 4 plus 5 and negative 4 plus 1. So we get negative 3 is equal to negative 4. We work inside the parentheses first. Oh, I'm so sorry. This is not even right. Take it back. Take it way back. Pretend that didn't happen. Okay. Y is equal to the a value we don't know. We're putting negative 4 in for each of the x's. So there's one of them. And negative 4 in for the other x. Plus 1. There we go. Now we're going to simplify. Oh my goodness, I forgot the y. It's been a great day. Okay. The y value was negative 3. Phew. All right, negative 3 is equal to a. Okay, now we'll go inside the parentheses. So negative 4 plus 5 is 1. Negative 4 plus 1 is negative 3. So again, parentheses mean multiplication. Negative 3 times 1 is negative 3 times a. That guy's negative 3a on the right, and then we still have our negative 3 on the left. So we divide by negative 3. A is equal to 1. So we stick that in there. So y is equal to, we have a 1 there, x plus 5. X plus 1. Now if you used the calculator method on this one, your answers are going to come out in standard form. That's just fine. If it's in standard form, it's going to look like this. So if this is what you got, that's fine too. Or on 16, again, if you use the calculator method, then your equation would look like this. That's just fine. Again, remember on the calculator method, so on 18 and 19, this says it just passes through these 3 points. There's no intercepts or necessarily the vertex. I guess there's a y-intercept. But this is the one where we would use our list 1 and list 2 inside our calculator. So remember, we push the stat button to get there. And then we want to input that information. So every point gets its own line in the table. And then the calculator will estimate as best it can how to calculate through those 3 points. Again, those steps are in section 3.6 of your notes. So once you have that in, right, then we go to stat again, and you go over to calculate and click number 5, quad regression. I think it just says quad reg, and tell it to calculate, and it will give you again that standard form. It will remind you what that standard form is, and then it will give you a value for A, 1 for B, and 1 for C. And whatever those A, B, and C values are, so for example, if you put this one in the calculator, A comes out and says that it's going to be 0.2, B is negative 4, and C is 1. So we would write our final equation in standard form, putting those values in, 0.2 for A. We would put in the negative 4 for B, and the positive 1. Now, those of you that are at home that will be taking this test online, just recognize this would be like a multiple choice test or question, and you would be given like maybe 4 equations. So maybe this would be one of them, and then you'd be given a couple other equations. The way that you can tell if the equation is correct is you could graph each one of the options and see if it passes through those points, or you can plug these x, y's in and see if they work. So if we plug 0 in for each of the x's, notice that would be like 0 times 0.2, so that just turns to 0. This would be a 0. 4 times 0 is 0. So we would have, when x is 0, y is 1. And notice that that works. If I put x in, you could also put a 15 in. If you chose 15 and put 15 in here, and then simplified this side, you'd end up with a negative 14 here. So you can check that. Again, if you plug this into the calculator into your y equals, it will also allow you to go to the table, and you could look at your table of x and y values and see if these points exist on your table. So a couple different ways you can do that. Again, working through this next one, we should end up with y is equal to negative 1.5x squared minus 4.5x plus 12. So using that same method. Last one, determine whether the pattern in the table is linear, quadratic, or exponential, then create the equation to represent the data. So first of all, our x values, notice, are just going up by 1, so that consistency allows us to just look over here at the y values and to kind of see what's happening in our growth here or decreasing. So if we look at this, it looks like the first one is decreasing by 11, then we decrease by 9, then we decrease by 7, decrease by 5, this one's subtracting 3, this one's subtracting 1. So this is similar to our quadratic equations, because notice if we were to jump out here, it's just adding or moving in the positive direction 2 units for every new output. So this means if the second difference is a positive 2, so that's kind of the pattern of growth that we see, right? The second difference is adding 2. That means that this is a quadratic function. And again, the quadratic function here, you're not necessarily given a vertex or anything, so what you could do again is just stick it in that table like we talked about, and we were just practicing this method one last time, and we could create our equation that would be the output here. So we would end up with y is equal to x squared minus 8x plus 18 as our final equation. So again, this table over here just kind of becomes that L1 and L2. And remember, you only need at least 3 points. So you only really need to use like these 3, or you can choose any 3 you want to create that quadratic equation.